If you're interested in exploring the manuscripts of Marie Curie, be prepared to sign a waiver and don protective gear to guard against radiation exposure. Madame Curie's remains are also laid to rest in a lead-lined coffin, containing the very radiation that was central to her groundbreaking work and likely the cause of her untimely death. Early life. Born as Maria Skłodowska in Warsaw, Poland, during a time of Russian occupation, Marie was a remarkable student who faced significant obstacles. Denied access to higher education simply because she was a woman, she defied the odds by enrolling in the Floating University, an underground institution that offered secret education to Polish youth. Through diligent savings from her work as a governess, she eventually moved to Paris to attend the prestigious Sorbonne. There, she earned degrees in physics and mathematics, often subsisting on little more than bread and tea, sometimes fainting from hunger. In Paris, Marie met physicist Pierre Curie, who not only shared his laboratory with her but also captured her heart. However, her longing for Poland remained strong. When she returned to Warsaw, she faced challenges in securing an academic position due to her gender. Fortunately, Pierre was waiting for her in Paris, and they married, forming a powerful scientific partnership. Scientific breakthroughs. Marie Curie's curiosity was piqued in 1896 when Henri Becquerel discovered that uranium emitted mysterious radiation that could affect photographic film. She quickly found that thorium produced similar emissions. Her findings indicated that the intensity of the radiation depended only on the amount of the element present, revealing that radiation originated from within the atoms themselves. This groundbreaking idea challenged the previously held belief that atoms were indivisible. The Curies began investigating a highly radioactive ore called pitchblende and soon realized that uranium alone could not account for all the radiation they observed. In 1898, they announced the discovery of two new elements: polonium, named after Marie's homeland, and radium, derived from the Latin word for ray. They also introduced the term radioactivity. By 1902, the Curies had successfully extracted a tiny quantity of pure radium chloride from several tons of pitchblende, a remarkable achievement. Later that year, while Pierre and Henri Becquerel were nominated for the Nobel Prize in Physics, Marie's contributions were overlooked. Pierre advocated for her recognition, resulting in the Curies and Becquerel sharing the 1903 Nobel Prize, making Marie the first woman to receive this honor. Tragedy and legacy. The Curie's success was abruptly halted in 1906 when Pierre tragically lost his life in an accident. Heartbroken, Marie dedicated herself to her research and took on Pierre's teaching role at the Sorbonne, becoming the institution's first female professor. Her independent research flourished, earning her a second Nobel Prize in Chemistry in 1911 for her earlier discoveries of radium and polonium, solidifying her status as the only person to win Nobel Prizes in two different scientific fields. Professor Curie applied her findings to advance medical research, establishing mobile radiology units during World War I and studying the effects of radiation on tumors. However, these contributions came at a personal cost. She passed away in 1934 from a bone marrow disease linked to her radiation exposure. Marie Curie's pioneering research transformed our understanding of physics and chemistry, leaving an indelible mark on oncology, technology, medicine, and nuclear physics. Her discoveries ushered in a new era of scientific inquiry, revealing some of the most profound secrets of nature.